Hi, everyone. I hope you hear me well. Today morning, when I woke up, I just realized that I'm going to be the only thing on the way between you and your beer in the evening, right? And actually, that came true. So I'm hoping to make. Thanks for joining during the prime time, evening time, and I'm hoping to make it enjoyable for you, so you can use that time best. What I'm going to talk about is give you a little bit of insight of our experience in the cloud. How did we make it through our system that is map making and location based, and how did we move what we had in the past? How did we move it to the cloud, which was pretty amazing experience for us, and what are the lessons learned from it? So to give you a little bit background of who we are, TomTom is in location business for quite a while, and location is something that surrounds us simply everywhere, right? So you have locations is all about things that stay, that typically are there on the earth, but also locations are about objects that move, and everything with the location and with the coordinates forms kind of a graph in the entire world, because all those objects, they are not just loosely coupled, right? In the real life, we have objects that are tightly coupled, and they form relations between each other. So you have, for example, your roads that are connected to each other, or you have your passengers in the taxis that are kind of connected via locations, right? Because they are inside, they drive for a while with the taxi. Also, those connections between the objects is not only about locations. Sometimes they are legally connected, right? So, for example, the fact that I have a sign that tells me that there is a speed limit actually is a legal implication of what is the legal speed limit for the next couple of crossings, for example. So you have to imagine that this forms quite a big graph that is surrounding the Earth, and it is the complexity that we are dealing with. We have been in the business for quite a while, and we are, the way we are approaching the business is that we collect the data that have any correlation with the data that we want to capture. And thanks to that, we have already, for all those 25 years, we have collected a lot of point data that is there. So you have the data that is being logged via devices, that is being logged via when you move, but also we capture the data from the special vehicles that run across the globe. These are called mobile mapping vehicles. And when you would look inside our database, we actually, till date, collected about 10 petabytes of data. So that's the volume that we have to deal with. That's the volume of the complexity that we have to deal with. And the data is growing, I would say, exponentially. I wouldn't make a mistake if I would judge that about 30% of the data that we have has been collected last 12 months, right? So maybe 30% is a rough judgment, but this is the nature. We forecast that data is going to grow and grow, and we have to manage that on the daily level. After we collect the data, what happens is that we have to process it. We have to process it to create a meaningful information for our users, which, as I said before, makes kind of a layered, connected information, right? So you, in the information that we deal with, we can identify a couple of layers, couple of things that are meaningful, such as route network, that obviously is used for routing, such as addressing, that is used for geocoding. So if you type an address, you want to search for something, then you see the results. Of course, traffic signs that give you the potential of having a better navigation experience. Things like POIs. Do you want to go to the restaurant? Do you want to go to the hotel tomorrow? That is used for your search. And all that content is getting richer and richer. So we started with basic road network, and as you see, we are every year, every day, we are enriching our content with the new types of data. So not only the volume that we have to deal with, but also layers of information that are new, that are enriching your map experience, your navigation experience, your location experience. Tomorrow, and for the next best experience of your map data, we start to collect the ADAS information for the driving assistance, and we are leaders in something that is called HD maps, so very highly precise maps that is going to make it through for automated driving in the future. So as we speak, we are ready today for the future of the automated driving. That's pretty big thing that we are achieving. And all of that happens thanks to the fact that we master collection of the data, master the source of information, and we have to process it fast, smartly, to get the meaningful information for our users. But that's not the end of the story, because all of that information that is coming from all different sources to us is passing through the next steps, right? Before it gets to your device, before it gets to your navigation system, before it gets to your phone, it typically passes to either backend or to the device directly. And this is where we partner with a lot of players around the world. So this is the extraction of probably the most known players on the market, but we deal with many receivers like that. So to get back into what we actually do is we do nothing more than we just collect the data, we process it, and we deliver it either directly to the device, either directly to your search systems, or via the partner networks for the other applications. And this is getting back to the complexity, right, of the problem. So if you think about that single junction that I showed in the morning, in the beginning of the presentation, multiplied by number of people in the world, multiplied by number of things in the world, and you will understand the complexity that we are dealing with. And all of those things are actually moving, right, typically, and changing constantly. So you have to take that information, process it, and deliver it to the next in line. And that sounds very simple, but to get to the proper user experience is actually a pretty complex thing to do. So a while ago, that was around 2014, we actually saw the future of how map making and how the location systems are going to be looking like. And if you would look those days into what we are actually doing, typical collection of information, processing of information, and delivering of information was done in a kind of a stepwise approach. So we have collected a lot of data first, process it then second, and deliver it in the batches, right? So typically you had a delivery of information every quarter. The processing of the information even lasted longer, and it was delivered to the next in line either via internet, that was already a good thing, but typically on the CD, right, or DVD, that was delivered to your car. And we understood that this is not the future. This is not the future of the business. We had to somehow redefine ourselves. And that demand for freshness and quality of the map, continuous data processing innovation that we had to do, defined our next step challenge that we had to face. That was to offer a real-time information, real-time maps to the market. So the complexity that I showed you in the beginning is actually rising by quite a number of big problems, because you right now have to be reactive to any change that happens in the world, unlike previously that you collected majority of information, then you process it and then delivered. Right now you have to react to any change of the information in outside world and pass it through as a single transaction to the end user device. And this actually brings entire complexity, because the sources that we collect have a nature of being imprecise or inaccurate, right? So there is no single source in the world that is both precise and accurate when it comes to information about the map, right? So it either can be not accurate in time, in XY coordinates, and what you have to do is when you process that source, you actually have to verify it. You have to multiple times verify it against multiple rules in the map-making system, so your map is still consistent with the actual world, right? So the fact that there is the single probe of data that gives you a trace on the GPS device can be a GPS error by itself. So you cannot conclude from single signal about any change in the world. You have to verify it against multiple sources, against multiple combination of the sources. So, and that brings, when we had to redefine ourselves, that brought a lot of uncertainty to us, right? Because you try to deal with the change of the system, move your quality up the stack, and you have to deal with it with the partial information. When you want to decide about migrating from one system to another, you actually don't have enough information to understand how the system will behave in the new world. So, and this is where we thought, actually, if we have, so much uncertainty in the decision-making process, this would be fantastically fitting to the cloud, right? Because we heard that the cloud is actually making you flexible. You can get your hardware on demand. You can deal with it, right? So that was kind of a thought that we had, but the problem was that we actually had to do both things. First of all, we had to migrate our system from the old school one that was delivery every quarter new information to the devices. This is something that we call the batch map-making system. We had to move it to the new system that is ready for delivering real-time maps. And in the same time, you had a challenge on-premise versus the cloud. How do I deal with it? Do I put the system on-premise? Do I have enough information? Or do I move it to the cloud? Normally, you would, in the typical decision-making process, you would kind of sequence things, right? But this is not what we did. Based on our early adoption of the cloud, based on all experiments that we have been doing during doing migration between the batch and real-time map-making systems, the information was good enough to actually understand that we should try to migrate in parallel. So we both wanted to deal with the complexity of migrating from old school system to the new era, and migrating in the same time from on-premise to the cloud, which even further increased our complexity. But you're going to learn later on that actually was a saver. That decision was a saver. So once we made that decision, we started to migrate their workloads from old system to the new one, while obviously doing it all the time, right? So the system obviously wasn't ready for all the use cases that it had to deal with. And we started to measure. We started to slowly migrate it, because from one hand, you want to go through as quickly as possible, but from the other hand, this is the living system, and this is quite complex because it has this 10 petabytes of data inside, and you have to continuously deliver the information to the end users, right? So despite of the fact that you have a new idea, new system that starts to work, you see that it starts to work, you have to still continuously deliver the product. So your map has to be up to date all the time. And so we approached that project, which was migrating all of those databases, all of those systems. We approached that project in the longer period of time. So as you can see, it is starting in January 2016, and the data that you see is up to September this year. And what I wanted to share with you is try to identify in that entire project that was held by about 300 engineers across the globe in TomTom, that impacted about 3,000 people in our internal production of the map. I tried to show you here a couple of phases that have been essential to what we actually achieved. So and I'm going to show you that in the context of a couple of KPIs. So first of all, how much the new system can produce, which is we counted in number of map changes that pass through the system to the end user. And second, obviously, the most interesting as well is the cost, right? Because when you think about migrating from on-premise to the cloud, it's typically the question about productivity, right? Which cost is one of the major factors in it. So I'm going to show you that in context of number of changes, cost, but also productivity, which would be the cost per change. And you're later going to see that you kind of, in that data, you see three phases that I named early migration, scaling, and optimizing. And different effects, both in the system, in the technical system, but also in the team, in the entire behavior of the company, happen in different phases of that migration. So you see the early migration, scaling, and optimizing. And as you can see, the number of map changes that were passing through the new system is growing here, right? But this is both a result of the fact that the workload was migrated, but also the fact that the system wasn't that ready. Because when you develop a new system, it is typically never ready. So it's quite a challenge to replace such systems on the fly. And so this is number of changes that are passing through the system. The second thing, the second KPI is the hardware cost. And you see another effect. That first of all, when you start to migrate the workloads into the cloud, your scale is growing, your system is picking up more and more workloads. But what you see in the end also is that the hardware cost is dropping. And this was a surprising thing for us, because what you saw in the previous what you see in the previous slide was that number of changes is growing, but the cost is coming down. So why is that? You're going to see. I'm going to talk it through in a couple of minutes. And the same view, which is your productivity. Your typical productivity figure, which is dividing the cost by number of changes that you do. And you see a couple of patterns there as well. So in your early migration phase, the cost seems to be pretty high, and it was, in fact, in our case, it was not acceptable. And we had to somehow deal with it during the scaling, during all the migrations, and further optimizing the system. All right, so if we zoom in to the early migration phase, what happened in that time is that, so this is starting in January and finishing around June. The team is, in the beginning, is quite enthusiastic about the change, so we are migrating both the workload to the new system and also to the cloud. And what we see is that the performance of the cloud, unlike some of us thought, was actually better than our on-premise, which was counterintuitive, because the on-premise is physical hardware, and you would expect physical hardware to behave a little bit better than the virtual machines. But that's what actually happened, right? That our on-premise infrastructure was less performing than AWS Cloud. And what we saw that thanks to that is the responsiveness of overall system was much higher on the cloud. And however, if you look at the June figures and the early adoption, early migration figures, what we got in the end of that phase is that we really have understood that the cost of the hardware on the cloud was actually not what we wanted to have. Right? It was pretty high, given the workload that was still not 100%. The cost was pretty unacceptable. And I cannot disclose the figures what was the on the y-axis because that's proprietary information. But I can tell you that this is not 1,000 euros. This is not $1,000. This is counted in million dollars, right? So the impact was pretty high. Impact on our budget, on our understanding of the business figures was pretty high, and it was in that moment we were pretty down as a team. We had multiple sessions about what do we do now. What should we expect? We migrated 80% of the workload to the cloud, but it seems we are not getting there. What's going on? What's happening? However, what we also understood is that the benefits of the new system itself is so high that we just want to continue, right? Because if you just take into account the cost, it would be probably a canceled project, right? But the benefits of having new system set up that gives the new user value, which enables the information to pass through the system instantly instead of quarterly, benefits are so high that we decided to continue after that phase, right? And that was quite essential as well, that in such case, when you migrate both things, where you redefine yourself, and in the same time you migrate to the cloud, this is the moment where you take both things into account, and you make the decision about the productivity, not about the cost itself. And this is, after we made that decision, what happened is that we entered the scaling phase. And in that phase, in the beginning, we actually compensated the workload, the remaining workload, with adding extra hardware. So we understood that the benefit of the new system is high, and that we want to risk for a while the cost that new workloads are giving us, to make sure that we continue, to make sure that we stay on the path. And this is in the end of the scaling phase. We actually saw that our on-premise infrastructure would never make it. So the workloads coming from such complex systems, such number of bytes to process, we would never make it in our on-premise infrastructure. These are the figures that of the traffic that we saw passing through the system. So you can see that the external traffic coming from the system, from the mapmaking system to the outside world, was about 40 gigabits per second. And the internal traffic, so all the communication inside the system, was even greater, was at around 200 gigabits per second. So pretty big thing that actually not many on-premise infrastructure can deal with. So what we did during the scaling phase, after we realized it, we made the final decision to make full workload move it to the cloud. What we did experience during the scaling phase was also the fantastic flexibility that cloud was giving us. Because during those couple of months, based on the workloads that we saw, based on the nature and characteristics, we were able to completely exchange 4 families of the hardware. So we, in the beginning, I remember we took I2 instances that were available those days. But when we finally scaled, we actually were able to convert it fully to i3s, which gave another user experience for the workloads that are making our map system in the cloud. What also happens inside the team in those early phases and in the scaling phases is that the teams are, thanks to the fact that you actually deal and on daily level you start to understand and try to control the costs, the team that was previously divided into typical develop and operational mode turns smoothly into the DevOps. So just by the fact that we have been dealing with the cost on daily level, our teams developed a culture that turned them to become a true DevOps. And in that phase, in the scaling phase, the teams start to get some cost control. So in the beginning of the migration, they were, I would say, we were lacking control when it comes to the cost of the workload. But in the scaling phase, what you see in the team, what is happening is that they start to get in control. And the last phase is a typical optimization phase that is just kind of a post-process that happens, that starts somewhere in the middle of the scaling system and continues all the way. It will continue probably until ever, right? Because you always want to optimize. But there's an important lesson learned after optimizing. Because what you see is how much we could optimize. So if you look at our overall cost per workload, per change, is we have been able to optimize by about 8 times. So from the initial migration to finally going and optimizing fully the system, we have been able to achieve so good cost predictability that it really was driving the cost down. Now that we know all the data, now that we all know that history, we actually can tell what would be happening if we would stay on premise, right? Because if you know what was your workload, if you know what was your cost, if you know all the data right now, you can actually judge what would be happening if you wouldn't migrate to the cloud. And that's the reason why in the beginning I said it was our main saver of the migration of the mapmaking system, because you actually, when you think you are on premise, you have only a couple of options. You are not so much flexible as you are on the cloud. So when you pass the early migration phase, you see the data that you see. You see only the data until June, right? From January to June. And you go into the point where you are about to make a decision. And you have a couple of decisions to do. You either are going to decide that you're going to go all the way. You're going to scale the system and optimize it. But to do that, you actually, on premise, you have to buy the hardware upfront, right? So if you would buy the hardware upfront to the on-premise infrastructure, what would be happening, knowing now that we have been able to optimize that much, what would be happening is that you would end up with I calculated that with about 4 times higher cost of the system than you ended up in AWS. And not only that, because of the fact that AWS turned out better than on-premise infrastructure, your productivity of the system when it comes to the time to market of the changes would be reduced compared to the on-premise, because the hardware is simply slower, so the changes are passing slower. You wouldn't be also, if you would be making a decision about buying the hardware on premise in that moment of time, you would have one chance to choose the right hardware, right? Then if you would choose the wrong one, you would actually live with it forever. The second thing that might have happened after early migration, we might have said to ourselves that, all right, that was a good idea with all that real-time map-making system, but it is too costly, and we're going to cancel the project. That what would potentially be happening with the decision. And then, of course, you always have an option to kind of try to be flexible on premise, right? And but for the on-premise infrastructure, it means that you have to take baby little steps. So you make a decision about scaling, optimizing, and trying to buy new hardware while you go. But that, obviously, if you buy new hardware, it takes a while. It takes a while before you make a decision to buy and the time that the hardware is delivered. So you would actually have little waiting periods in between. And that, what would happen with that is that your system, in that case, based on the data that we see, would reach the market two times slower. So we would probably be still in the middle of migration of that system. And of course, the same on-premise means reduced productivity. And this was from the decision-making perspective. However, of course, what happens when you migrate to the cloud is that you see reaction of your team, reaction to that, right? To the change that we experienced, and this I asked around from our team before that session. I asked around what do they think about the experience of the cloud, and what do they think if it would be staying on premise? What would they lose, and what do they gain with staying with AWS? And this is the voice of the team. So you see that they say we are more productive, more flexible. We can test the scale, which is for us it's quite essential, given the data sizes that we have. We have better hardware fast, right? And our costs are not fixed. So you can delay your decisions. You can try to understand as you go what would happen with the system. Now, what did it mean to our business? So in the beginning, I told you that and all the market was like that before. Our data freshness, so our map freshness, was counted in months, right? So you see what you see on the chart is that our delivery in 2015, between the change that was happening in the real world and when the data actually made it to the device, was about 150 days. So 150 days, if somebody some city made a decision to change the traffic rules, it was 150 days that our customers were suffering, right, from that change to not be noticed in the data. And what you see is the chart while migrating, how the system was targeting that need. So today, we already deliver the information weekly. So compared to 150 days before, it's right now 7 days. And the only reason why we do that is that we keep a buffer, a safety net still in the system. So it's not the full system capability, but we still have a safety net when it comes to our quality system to keep a little bit of the buffer, observe the system for a while, for a longer while. So far, it doesn't give us really any surprises. So what we know is that next year we are going to be targeting real-time maps. And thanks to the fact that we have decided to migrate the system and the infrastructure, that what happens is that it made us really, really far ahead against the well-known competition. And this also, because we have to deliver to the customer, we are ahead of the market needs thanks to that. And we actually right now are helping our customers to get ready for our fresh data. And of course, operational results is that we are more productive than on-premise. and we are more productive than on the old system. What will it give for the customers of TomTom in the future is that that system is capable right now to target really advanced needs of the future. So if you think about autonomous driving, the map that stays that is delivered to the autonomous vehicle has to be really accurate and really fresh. So it's not only accurate about position, XY coordinates, but also in time, you have to detect the change and pass it to the vehicle very fast because it's about safety. And safety is very valuable thing. It's also enabling other use cases like smart cities, right? The information, if in smart city the information would go from the city to the citizen in 150 days, that wouldn't be really smart, right? So, these are the expected benefits that we see on the products that we are making. The upcoming future with this information processing moving forward is that we are going to see, and we are going to see the trends with the data size growth, and that will come that will come year by year. We don't see yet a limit to it, but what we're going to see is that the useful information is actually going to be a fractional part of the data that we collect. So today is already when we compare the number of bytes that we collect versus the number of bytes that are in the map, is already a ratio between 1 to 200. Right, so you collect way more information upfront, way more data to come up with the map that can be fitted to the device, and we expect that ratio to actually be growing because the number of connected devices, the number of noise that is going to be generated by these devices, they will contain obviously a very useful information, very fresh information, but it's also going to be noisy. So what we are forecasting is that that information is going, the number of information growing is going to start to reach physical limits, and we will have to switch to full incremental processing of our data. So it's not only collecting all the data that we're going to have and processing it, but also filtering it upstream and downstream in the map-making chain. And the technical consequences of those couple of things is that we expect to further innovate on our data processing capabilities, but that would mean that we will have to go, like we migrated to the cloud to the typical compute EC2 devices. We are going to go up the stack. Why? Because we have to keep up with the pace of innovating. So we already start to experiment with the things like Kinesis and other serverless things that will help us to catch up with the growth of information and the noise that we'll have to process. So we can just focus on our business and let the cloud providers deal with the problems. So just to conclude about what are the lessons learned from what we see. Remember, I told you in the beginning that we have been making a kind of a choice between migrating to the cloud and migrating to the new system. And if you are ever making such a choice, so if you think that you have to do things in sequence, that's not necessarily always true. Sometimes you just have to deal with the complexity and try to manage it, because the benefits from going to the cloud, especially when you have uncertainty, like we had during migration of the old system, the benefits of the cloud are probably higher in such case than typical migration benefits. right? Because you have so much uncertainty in the new system that the cloud allows you to deal with that problem way better. And this is what we did. We also, the lessons learned from it is that it can take you quite a while when you migrate or create a new system to actually come up with the final optimization. So, so we saw those charts that we actually went all the way, right? All the way reaching the sky limits of the costs. And that might happen. While you're migrating, that might happen. Like it happened to us, it might happen. But you just, in the moment of analyzing the data, you have to try to judge whether, is it really about the cost? Is it really going to be like that? Or is it, my system is not optimized yet, right? And you saw how much optimization of the system can give you. And it was a mix of different things, like just better code. A couple of bugs in the code that we had to find. A couple, of course, I'm exaggerating. It was more, and also not optimal code, but also understanding how to use ready-to-use tools like auto-scaling in AWS, right? As well, it takes you quite a while to learn it. So, so that's our lessons learned, and I hope you enjoyed this session. And if you are about to make your decisions like that, try to learn from us and take this home. Right. Thank you very much.